started.
Wait.
What am I waiting on? F of x plus h. What is that? Everyone agree? Did y'all do that on the test correctly? If some of the work's right. If some of the work, then you'll get a point for that. Who's your best?
So easy.
Is this the one we had on our list?
No, but similar. Not the exact. I don't know. Maybe it was. I don't know.
I think it
There was one that was like a fraction.
One of them was a fraction.
I think there was one that was like,
Oh, yeah.
I hate those.
Do you hate those things? Dalton, do you hate those?
Okay, everyone agree? 2x minus 3? Okay.
Mine's
Average rate of change of the following lines. 1. How'd you get that?
goes up, goes up.
Rise over run, right? Rise 1, run 1. What about this one? What'd you get?
Negative.
1/4.
Next one.
-4, yes, definitely.
Okay, I can see where lost.
Just put a negative one exponent at the bottom.
Where does it?
Okay, let's see if we can find one. Crosses. Here's a point, and here.
Oh, yeah.
Oh, I say 5.
It's kind of hard to see.
But if you said -4 and you were doing it right, that sounds great to me. What about this one?
0. Put 1.
I know. I tried to put 0. My smart board's not thinking as fast as we are. This one you can't tell because you can't. Yeah, it's. Yeah, I don't know. It's probably bigger than 10 because.
It goes past 3.
No, wait, that's 5 and -5.
Yeah, that's right.
No, wait. Maybe 6.
I mean, 6. Maybe 6 would be 12.
No.
Oh wait. Yeah, you're right. 10. Yeah, 12.
It's still 11.
It's not
Okay, what about this one? This one I think we can do because I think it touches here and here.
Negative 1/10.
5s.
5.
And what about this one?
Undefined.
Big thing you need to know is average rate of change of slope, and slope is rise over run. Today we are going to look at what in the world that difference quotient means. The difference quotient that you have been looking at with the limit as h approaches 0 in front is a derivative, and we want to look at why that is important. So I've got a little...
Video.
It's not really a video. Okay. So, if you just look at the difference quotient by itself, okay, would you agree that it's y2 minus y1 over x2 minus x1?
These are confusing me. No.
Yes.
Okay, so y2 would be f of x plus h, y1 would be f of x, and then x2 would be x plus h, and x1 would be x. Well, you subtract those, you just get h. So, f of x plus h minus f of x all over h is really just the slope between these 2 points. Does everyone agree? H is the difference between the 2 points. It's how far away they are on the x-axis. which is kind of like delta x. In fact, some textbooks will use delta x instead of h. I like h better because delta x takes me longer to write. And if you haven't noticed yet, I'm lazy. H is faster. But delta x is a good explanation because it's changing x. So this is a secant line. A secant line is a line that goes through a curve at 2 points. Now it could go through a curve somewhere else, but it goes through those 2 points, make this what's called a secant line. Finding the slope of this is something you've done since Algebra 1. y2 minus y1 over x2 minus x1. And that gives you average rate of change, which is very useful in some contexts. However, instantaneous rate of change is more important in most contexts. For example, if I'm driving from here to Fort Smith, does the police officer care if I average 55 miles an hour or not?
No.
What's he care about?
How fast you go at that time?
How fast I'm going when I drive by his radar, right? And that's called instantaneous rate of change. If I'm looking at a curve, the instantaneous rate of change would be the slope right there. Everyone agree? The slope when that point right there, which creates a problem. And before calculus, you couldn't find that, right? Because there's not 2 points, so I can't find a slope.
1 point.
But if I look at the limit as h approaches 0, wouldn't I approach those 2 points being the same? Which brings me to a tangent line. This is a tangent line. The slope of that tangent line gives me the slope at any point along the curve, which is nice to know. So it doesn't give me an average rate of change. It gives me an instantaneous rate of change. That is a derivative.
Oh, crap.
Geometer sketch pad. It's a pretty cool one. You can make little things like that in it.
We're supposed to doing derivatives on the weekend before.
Yeah. Yes. Okay, so write this down. This is the definition of derivative. Now you can skip this middle step if you wish. What happens to those x's?
To cancel.
They cancel and just give you h. But the derivative of a function is the slope of the curve at a point. And you find that by doing the limit as h approaches 0 of f of x plus h minus f of x all over h. There are 2 notations for the derivative. The first one is read f prime of x. The second one is read dy over dx. The reason there are 2 different notations is there are 2 very famous mathematicians that came up with calculus at the same time. Supposedly completely separate from each other. Of course, there are major accusations of plagiarism and whatnot. It's quite the controversy in the mathematical world. One of those people is Isaac Newton. You may have heard of him. Kind of an important dude. He created calculus because he needed it. What is Isaac Newton famous for?
Laws of motion.
Physics, right? Lots of things, right? He is very famous in the science world. Well, can you imagine he needed calculus to do his science stuff? Kind of important. The other notation came from a person who was more of a pure mathematician, who just was studying mathematics. His notation carries over a little better into high-level calculus, beyond Cal 1. That dy dx notation is his. Why do you think he used dy over dx?
Derivative of y, derivative of x.
Change in y over change in x, kind of like delta y over delta x. Make sense? except he was using a different symbol than delta because the change in y and the change in x are what he called infinitesimally small changes in y and changes in x. So he used a different letter than delta to show the difference between those two. Newton called his fluxions and was a little different. There's an interesting book, Tour of the Calculus, I believe it's called, by David Berlinski. I have it back there somewhere. Anyway, if y'all are interested in the history behind calculus, if any of you are as nerdy as I am, then it's a good read. If not, maybe not. But anyway, so it kind of talks about where their notations came from and how they chose those. So. Any questions so far? So, we are not using shortcuts. If you know shortcuts, forget you know them. We will talk about those later. For today, we're going to find derivatives the long way, but now we kind of know what we're doing. So we're doing a little bit more with practice, but we now have more knowledge. Coming back in here. So try. First one's so easy it's hard. So let's write it out first of all. The derivative, which is called f prime of x, is the limit as h approaches 0 of f of x plus h. Well, what is f of anything? 7. Why?
Because there's no slope.
There's nothing to plug into, right? F of 0 is 7, f of 1 is 7, f of 10 is 7, f of a million is 7. It's all 7. F of x is 7. So I get the limit as h approaches 0 of 0 over h. Now that is a 0 over 0 limit, but probably best done numerically. What do I mean by numerically? Plug some numbers in for h. As h approaches 0, what's really close to 0? 0.001. What's 0 divided by 0.001?
0.
What's 0 divided by negative 0.001? You agree that equals 0? What is the derivative again? Slope of a curve at a point. What's the slope of y equals 7?
0.
Does it matter where you are? No. So does it make sense that we would get 0? Just a quick guess. What do you think the answer to the next one is? It better be, right? If it truly is the slope of the curve at a point, the slope of a line is going to be the same anywhere along that line, right? Makes sense. So let's try it. I get the limit as h approaches 0. Negative 8 times x plus h minus 2 minus negative 8x minus 2 all over h.
Yep.
Negative 8h divided by h is negative 8. Does it matter what x is? No, so f prime of x is negative 8, which makes perfect sense. However, on a parabola, is the slope the same all the way around the parabola? No, in fact, it's going to change depending on what x is, right? So you remember when we did some of these and you're like, is my answer supposed to have an x in it? Well, if we are finding instantaneous rate of change and the slope changes as you go along the curve, then yes, you would have an x left in because the slope will be dependent upon where your x is. So we will find it. Feel free to pay attention to patterns. I recommend you not ask someone what the pattern is, but that you try to find it your very own self. Some of you have already figured it out. You need to keep your mouth shut. There are shortcuts for how to do this. When you see them, you will be very mad at me, probably.
So why are we going to the long way?
The short way has no tie to a slope, and you could be able to do it and have no idea what you were doing. Right? Because you learned it for Quiz Bowl a year ago, 2 years ago. Did you have any idea what a derivative was?
I think I heard the definition like once or twice, but that was it.
Yeah. You could teach a 7th grader how to do derivatives. They would have no idea what they were doing. But you could teach them. So we need to have a little better understanding than just a shortcut. We will use the shortcut very soon. Give me a couple days. But I do encourage you to watch for patterns. That way when I try to get you to figure the pattern out, you already have an idea. Believe me, I'm ready for you to know the shortcut because I'm tired of writing this stuff. Because remember, I'm lazy. Okay, the x squareds cancel. I kind of buy into the work smart, not hard principle. You know. Factor out an h. Limit as h approaches 0.
Yeah.
And as h approaches 0, what does that approach? So the derivative at any point along that curve is 2x plus 1. Does it make sense that that would change as we go along the curve? Okay, let's do another. Today? No. You can't use shortcuts today. You must use long ways. Today? No. Eventually? Yes. Do it. You cannot use shortcuts today. Yes. Not yet. How in the world do I do a limit that looks like that?
Plus. You can't change it.
Okay, it's a conjugate from multiplied by the conjugate. This is good limit practice for us. What happens on top? The x's cancel and the 3's cancel. And I'm just left with an h on top. Sorry, lost my denominator. Okay, So the h's cancel, but I am left with x plus h minus 3 plus the square root of x minus 3 on the bottom. Correct? And now I can put 0 in for h, and I get 1 over 2 square roots of x minus 3. Those of you who know a shortcut probably don't know one for that. 0 in for h. Don't worry, there is one. You just don't know it yet. Okay, next question. Find the slope of the tangent line to the graph at the given point and then find the equation of a tangent line. Well, let's go back to this picture. Talk about what a tangent line is. A tangent line is the line that just touches this curve at one point. The slope of the tangent line is the derivative. Right? How do you write an equation of a line? What do you need? Slope and y-intercept is perfect. What if I don't have a y-intercept? What we'll do? A slope in any point. We can work with a slope in any point. Agreed? We can use point slope form. It turns out the slope is the derivative. So the first thing I'm going to do is find the derivative. Don't worry, we won't do 100 of these. Maybe 99. No, just 2. Not a couple of days ago, maybe a week ago, this was hard, wasn't it?
Little.
Now it has become tedious.
Yeah.
It's no longer hard. It is still tedious. Uh, 2x maybe?
Yeah.
Oh, whoops, I lost a 9. Minus 9. Sorry. The 9's cancel. Factor out an h. So, f prime of x is 2x. Remember, this is the slope of the curve at any x. If I want the tangent line at -1, -8, where do I want the slope at? At -1. Everyone agree? So f prime of -1 is -2. That is my slope of my tangent line. My tangent line is y minus, anyone remember how to work that formula? Okay, good. Y minus y1, which would be minus -8 or plus 8, equals m times x minus x1. Does everyone know what formula I just used there? Point slope. The wonderful thing about calculus is you can leave it like that. I would highly suggest it.
So we just.
Yep, we found a tangent line to that graph. We could graph this in our calculator, and we could graph this line in our calculator, and it would look like a tangent line at the point -1, -8. I'm going to skip that one for a moment. And I'm going to talk about differentiability. You've seen this question come up on some AP problems, and I always answered it for you. Said it is or isn't. Well, let's talk about it. For a function to be differentiable, that limit has to exist. As you can imagine, not all limits exist. A derivative is a limit. There's a chance it doesn't exist. So we need to look at when it may or may not exist. And there are 3 cases where the limit does not exist, and really 4, but 3 special cases, and then I'll tell you about the 4th. The first one is at a sharp corner. What is the slope on this side of this function? What is the slope on this side?
1.
So, yeah, so -1 on the left and +1 on the right. As we approach 0, do those get any closer together? It's just -1 on the left and +1 on the right. Agreed? So at 0, what's the slope? The left, it's -1. The right, it's 1. What happens when the left and right are different?
Don't exist.
The derivative, the limit doesn't exist, right? So, at a sharp corner, any kind of sharp corner, where a curve is not smooth, the function is not differentiable. Not differentiable at a sharp corner. The second one is a cusp, and it's for the very same reason. Would you agree, as I approach from this side, the slope seems to be negative, and then as I approach from this side, the slope seems to be positive? At 0, there's no smooth transition to that. There's no limit on that, so does not exist there. The third is a vertical tangent, and I'm going to pull my... I don't have a tangent line up there. Well, I'll just use the other picture then. I thought I made a tangent line on that. Guess not. Okay, so I'm going to look at if I had a tangent line on here. So down here I have a tangent line. As I approach 0, what happens to the tangent line? It goes straight up. What's the slope of a vertical line? Undefined. Well, if this slope is the derivative, then at 0 right there, the derivative would be undefined or not exist because we have a vertical tangent line. Which makes sense because we know slopes of vertical lines don't exist. So the third place is at a vertical tangent. There is one other place that a derivative does not exist. And that's at any discontinuity. Because I can't look at the slope at a point if there's not a smooth transition. So any discontinuity, the limit does not exist on a derivative, so it's not differentiable. So the word differentiable means there is a derivative. So if I ask you if a function is differentiable or not, that's the question it's asking. Is at that point, is there a derivative? So quick question, true or false? If a function is continuous, then it's differentiable. Why? Good. Sharp corner, is this continuous? Yes. Is it differentiable? No. If a function is differentiable, then it's continuous. Yes. So the first one is false. Second one is true. So differentiability implies continuity, but continuity does not imply differentiability. So they are related, but they aren't the same. Okay, let's look at this question. AP practice question. Given f of x as shown in the figure, at which point is the function continuous but not differentiable? Answer on your paper. Like everyone have a second. I want to know if it is continuous but not differentiable.
Why isn't because D is curved?
Yeah, you're right. D is almost there, but I think it does smooth curve on D. B is clearly not a smooth curve. Everyone agree?
Yeah.
I could see an argument for D, but if I have to choose between the two, I'm going to choose B. So evidently they're saying D kind of smooths out there. You can see it more on D than you could on B. It definitely does not smooth out on B. Good. I already said that. Differentiability implies continuity. All right, let's look at this one. Get rid of that. Suppose x squared minus 2x plus 1 is f of x. Find the slope of a secant line. Find the equation of the derivative. And find the slope of the tangent line. Question, what in the world is a secant line? Goes through 2 points, right? So how do you find an equation of a line or a slope of a that goes through 2 points? Which class should you pretend you're in?
Math.
Algebra, right? A secant line is rise over run. Now, this is an x value and this is an x value, right? x1, x2. So what do I need to find the slope? I need the y values, right? And then x2 minus x1. How would you find y if you know x?
Plug it in the equation.
Perfect. F of 4 minus f of 1 over 4 minus 1. Does everyone agree that is an algebra 1 slope? Yep, it looks a little yucky, but it is. F of 4 is 16 minus 8, which is 8 plus 1 is 9. F of 1, 1 minus 2, 0.
So it'd be 3.
So the slope of the secant line, and actually it only asks for the slope. But you're right, if you wanted an equation, you do y minus y1. That x2 minus x1. So this is y2 minus y1 over x2 minus x1. So what I did, and I'm going to put that on here. 1, 2, 3, 4. I found the slope of that line. Right. Any questions about that? That is a secant line. Find the equation of the derivative. How do I do that?
Y minus 0 equals 3 x minus
X plus h squared minus 2 times x plus h plus 1 minus x squared minus 2x plus 1 all over h. X squared plus 2xh plus h squared minus 2x minus 2h plus 1 minus x squared plus 2x minus 1. X squareds cancel, 2x's cancel, 1's cancel, h factors out of everything left, and I get 2x plus h minus 2. So f prime of x is 2x minus 2. Does everyone agree? Okay, that is the equation of the derivative. How do I use that to find the tangent line slope?
plug in 3.
Good. So that is the slope of the tangent line. Any questions about that one? Let me see if I want to do any more. We'll talk about those. Well, I guess I can go ahead and say it.
Wait, when do we use the x minus x1 equals the slope? Or
y2 minus y1 over x. Secant line. Slope of a secant line. Tangent line is a derivative. Okay, I just want to mention there are two other ways the derivative can be represented. And we'll talk a little bit more about how to use these other two things on Monday, but these are just other ways the derivative can be represented. Notice this first one is almost identical to what you learned, except they use a delta x instead of an h. Some teachers will use delta x instead of h. To me, it's easier to lose the delta and the x and get them mixed up and messy handwriting and all of that fun stuff. So I like h better, but delta x means the same thing. The other one is different, and it's f prime at a specific number. So if I wanted f prime at 3, I could do f of x minus f of 3 over x minus 3, and the limit as x approaches a. And why that also works. So if this is f of x and this is 3, as x approached 3, would that give you the same thing? F of x minus, it would give you the same. So it's just an alternate definition of derivative, just mental note. I want you to do as many of these as you can. If you come to one you can't do, we'll probably actually take this up on Tuesday, but you will get new homework on Monday, so use your... if you do it that way, you will have double homework Monday night, but it's okay if that's what you want to do. But I do want you to do as much as you can. Do end up with a couple questions. Derivatives are brand new, so that's okay. How do we feel about what a derivative is? Good? All right.